All right, guys, let's look at the first question here. The first question says you've got a function. They give you this function. Something weird, though. The function has a p in it, okay? And you're asked to find the relative max, the relative min, and the POIs, okay? You have a question similar to your test, and hopefully by this time you've figured out that warm-ups are usually on your test, and the notes that I give you right after the warm-up, usually if we do extra problems, those are usually on your test also. Okay, find the relative min, find the relative max. You've got a y equals, justify your answer. All right, if you're looking for relative mins or relative max, what two methods could you use? One of two methods. What are they? Do you remember? The first derivatives test or the second derivatives test, okay? One of two. Let's just go ahead and try the first derivatives test. If it doesn't work, we'll try the second derivatives test, okay? Usually, the second derivatives test is faster, usually, okay? But you still got to know the point. And if you don't have the point, you still have to do critical points. So I don't know that it's any faster unless you already know your point. All right, so let's do the first derivatives test. Well, it is a first derivative test, so let's go ahead and take the first derivative. Some of you guys are really good about this on your test. Like, instead of leaving your paper blank, you actually just took the first derivative and got a point. That was pretty smart, I would say, because think about that. If you did it for all 20 questions, think about that. That's like 20 points, okay? So, of course, we're going to have to find at least the first derivative, all right? And then what you're going to do is you're going to solve for x, and that's going to give you your critical points, okay? When f prime is equal to 0 or when f prime is equal to d and e, those x values, when that's true, those give you what's called critical points. So over here, I'm going to pull out a 3x. I'll get x minus 2 is equal to 0. So x over here is equal to 0 or x is 2, and those are my two critical points. On this side, I have no fraction, and when you have no fraction, you always just get 1 is equal to 0. So on this, I have no critical points. All right. On the first derivatives test, what do you do with your critical points? What do you do with them? Okay, you put them into a number line. What if you were doing a candidates test? If you were doing a candidates test, what would you do with the critical points? You put them into a table, okay, a T-chart. Everybody good with that? First derivatives test, we're going to put them into a number line, and you figure out plus, 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 minus, 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 okay? Some of you guys are still not labeling your f prime, okay? I would strongly suggest that because now we have f prime and we have f double prime, and who knows, you might try to plug into f prime, okay? So make sure you plug this in and put in f prime and plug into f prime. All right, so where is my f prime? Oh, let me call it y prime. This is actually called y prime here. So do you guys agree that this is also equal to y prime right here? Okay, and it's a little bit easier to plug into this function, but if you wanted to plug into this expression, that would be totally fine too. Okay, what are some good numbers to plug in? What's a good number less than 0? Negative 1. Good number between 0 and 2? 1. A good number bigger than 2? 12. Okay, so guys, when you plug in negative 1, are you going to get a positive or negative number? Just positive or negative is all I need to know. It's going to be negative times negative, right? So that's going to be positive. All right, when I plug in 1, am I going to get a positive or negative number? You see it's positive times negative, so that's going to give me negative. And when I plug in 212, am I going to get a positive or negative number? Positive times positive, which is positive. Are you guys comfortable with that? Okay, and guys, when I know what y prime is, because I know when y prime is positive, y is increasing, and I know when y prime is negative, y is decreasing. And if I move between the top row and the bottom row, I have a relative max on y. Make sure you understand that's on y. And I have a relative min if I move from the bottom row to the top row, and that relative min is on y. Okay, we usually say on f, but in this picture it's on y. And remember, guys, y is in another room, okay? We're trying to figure out if we could see y, where would the relative max and relative mins be? Okay, so here we are. If y prime is positive, I know y is increasing. If y prime is negative, I know y is decreasing. All right, so I get this kind of this sketch for y, and just looking at the sketch, I can see where the relative max and min are. You guys good with that? So where is my relative max?
0.
Okay, at x equals 0. What's my y value for this relative max? How do I find it? How do I find the y value? Plug it into y or y prime? Y. Okay, so if I go up here and I plug in 0, what do I get for my y value? P. Okay, so my y value is P. Are you guys okay just leaving the P there? Just leave it. We don't know anything about p. It's just some constant, okay? Let's find my relative min. My relative min is where? What's the what's the x value of my relative min? 2. Are you guys good with that? Where did I get the 2? Guys, you just look at your number line and you see the relative min happens at 2. The relative min on y, right? That happens at 2. All right? Guys, how do I find my y value at 2? Plug it into y or y prime? Y, okay? Because it's a relative min on y, okay? It's the y picture that we can't see. It's in another room. All right, so y is going to be equal to 8 minus 3 times, guys, make sure you square, order of operations, make sure you square before you multiply. That's going to be times 4 plus p. So that's going to give you what? Negative 4 plus p, is that right, guys? All right, so you can put negative 4 plus p right here. That's fine. I'm going to put p minus 4, which is exactly the same thing. I'm okay with both of those, all right? Let's do our justification. What's the justification for relative max? Because what? F prime changes from what? Can I say negative to positive here? Would that be right? No, guys. You have to work left or right. And over here, you see that F prime changes from positive to negative. And that's why you have a relative max. Why do you have a relative min? What's your justification? F prime changes from negative to positive. Leave him alone. He has to be good at something. Okay. Negative to positive. You guys good with that? Okay. So here, can you guys justify on your own? Question. Can I say for the justification, actually, just to make sure this is right, guys, this F prime should be Y prime. I did this wrong. If you guys make a silly mistake like that, actually AP won't count it wrong. But if there is another graph called F, does that make sense? If there's another person called F or another graph called F, then that would be wrong. Okay, but if there's no other graph, you accidentally call your F Y's or your Y's F. It's not a big deal. Okay, over here, guys, could I say the justification for relative max? Because remember, these are synonymous. Y prime positive means Y increasing. Can I say the reason for relative max is because Y changes from increasing to decreasing? Can I say that? No. Why not? It's true. You're right. It's true. But why can't I say it? Because it's a definition, not a justification. Does that make sense on the AP test? Y increasing to Y decreasing is not wrong. I mean, it's wrong as a justification, but it's a true statement. Okay, so when you're justifying, always use your primes. Okay, don't use your Y's for justification. All right. Okay, let's look at POIs. Done my relative max and min. Oh yeah, Brant. Sorry.
Could you say that it changes signs, or would that be too vague?
You can't just say it changes signs because you could do that on a POI because it doesn't matter if it's positive or negative to positive. Does that make sense? On relative maximum, you got to get it in order. Oh, the other thing is, don't ever say because it changes. Does that make sense? It is not your boy. Does that make sense? You got to name your boy. Okay. So it's got to be because F prime changes, or F double prime changes, or G changes. Does that make sense? G prime changes. It can never be the word it. Guys, it can never be the word the graph either. Okay? The graph could be any graph. Okay? So please do not say the graph. So anyway, those would all be kind of wrong on my test and also on AP test. All right. Let's look at find the coordinates of the points of inflection and justify. So here we go. Guys, keyword, point of inflection. Which derivative do I need? Second. All right, let's go ahead and take the second derivative. Oops, sorry, y double prime. That's going to be 6x minus 6. I'm going to set that equal to 0, and I'm going to set that equal to d and e. All right. On the d and e side, I'll get no critical points because it's not a fraction. Okay. On this side, I'm going to get x is equal to 1. Okay. Actually, that was a misnomer. These aren't called critical points. What are they called? POIs. Yeah, possible POIs. So no possible POIs from the D and E side, but I have one possible POI on the F prime equals 0 side. Okay, and that's at x equals 1. Okay, so now I'm going to do a y double prime number line. So everybody with me? Okay. Guys, this is pretty much the critical point of the y prime. It has a new name. Now it's a possible POI of the y graph. Okay. All right. So I've got y double prime here. So what I'm going to try to find out is if y double prime is positive or negative. So I choose points on my interval. What's a good number less than 1? 0. Good number bigger than 1. Thank you. All right. So then you're going to plug it into your y prime. No, sorry, into your y double prime, right? And you're going to figure out if y double prime is positive or negative. If I plug in a 0 here, do I get positive or negative? If I plug in 212 here, do I get positive or negative for y double prime? Positive. Okay, so guys, this is my y double prime graph. So it gives me a picture of my y graph by using concave up and concave down. You guys good with that? So now I have to decide, is there a POI at x equals 1 or not?
Yeah.
Yes, okay. Why is that? Well, I'll justify it in a second. If the POI is at x equals 1, what's the y value? Remember, it's a point of inflection, right? So you got to give me a point. What's the y value of that point? Yes, do you see you plug into your y here? Okay, make sure you understand. So I'm going to plug into my y here, not my y prime, not my y double prime, because I'm trying to find the POI on f. This is going to be 1 minus 3 plus p, which is what, guys? Guys, are you comfortable writing p minus 2 on your test? Okay? I mean, if you're not comfortable writing p minus 2, then you should just be comfortable missing it on your test. Okay? So just write down p minus 2. There's nothing wrong with having a p in your y answer. Okay? All right. So then I need to justify this. What's the justification for a POI? So let me go ahead and write this for you. Guys, you must have this memorized. Okay? It helps you so much. Okay? And understanding what it means helps you so much also. Okay? To justify a POI, you can move from one row to the other. And do you see it doesn't matter for POIs which row you move from. Everybody good with that? Okay? So, what's the justification here? Because what?
Y double prime changes sign.
Very good. You would say y double prime changes sign. And that would be your answer. Guys, I'm going to write some answers up here, and I want you to tell me if it's okay or not. What if I said y double prime changes from positive to negative? Is that a justification here?
Yes.
No.
Okay. At x equals 1, so at x equals 1, is y double prime changing from positive to negative? No. What's it actually changing from? Negative to positive. Okay, make sure you understand that. So we say the signs don't matter. The signs don't matter if you don't write the signs, okay? But if you write the signs, you better write the right sign. Is everybody good with that? Okay, you got to write something that's true. Okay, could I say y prime changes from increasing to decreasing? Can I say that? No. What could I say, though? From decreasing to increasing. That would be okay. All right. For the justification, can I say this? Can I say y changes from concave down to oops, I can't use that for justification. Guys, you can't use this intersection sign, so you have to write down. From concave down to concave up. Is that a justification?
No.
No.
Because that's exactly what you're saying.
No, because that's a definition. You guys agree with that? Okay, so just to make sure you understand, this is a true statement, but it's not a justification. Okay, tricky. Okay, I don't know how to spell justification, but it's tricky. It is a true statement, but it's actually the definition of a POI. You guys good with that? So you cannot use it for a justification. So make sure when you guys are pulling for justifications that you only pull the derivative parts. Okay, please don't pull the F parts or the Y parts. These are the definitions. Okay, all right. Now that you're completely confused, let's do this problem. For which value of x is there a local minimum? Guys, if you get a table on your test or on your AP exam, convert the table to a number line. Okay, that's where it's going to help you. Okay, students who don't do the conversion usually miss this problem. Okay, students who do the conversion most of the time don't miss this problem. Okay, so let's go ahead and convert this. Convert this to an F prime number line. What would be my critical points on this F prime number line? Negative 3 is one, 2 is another. Okay, then look at the number lines. See what they're telling me. They're saying, hey, look at these. These are the signs of F prime. Remember, that's what I did when I tried to plug into the intervals, right? So in this interval, what are the signs? Negative. What about between negative 3 and 2? What are the signs for f prime? Positive. And what are the signs for f prime? This is really when x is greater than 2. When x is greater than 2, what are the signs? Negative. And what do the signs tell me about f? When f prime is negative, f is decreasing. When f prime is positive, f is increasing. So here's the question. Where do you have a local minimum? At what, guys?
Negative.
At x equals negative 3. And on this problem, can you find the y? No, you don't have a function, so that's all you would know. You'd know the x value for the relative minimum. Any questions about that? All right, guys, super easy problem, but you gotta draw your f prime number line. Okay, go ahead and pass up your warm-ups. Here's another question that's on your test. Okay, here's another question that you will see on your test. Okay, it's a super easy question once again if you draw your number line. If you don't draw your number line, it's really hard to just look at it and get the right answer. Okay, this is asking you, this is telling you h has a relative mass at 4, and tell me, oops, this is not what, I don't even have a choice here. Tell me which one's true. Let me put B here. H prime is positive. No, H prime is negative. There should be a multiple choice. Sorry about this. I erased it. On 4 to infinity. Okay, so between these choices, which one is true? Is H prime negative from negative infinity to 4, or is H prime negative from 4 to infinity? Okay, so let's draw a number line. Okay, I'm going to draw this H prime number line. Do you see what you'd use for your critical point? 4, okay, because maxes and mins happen at critical points, okay? If I have a max at h, do you agree that h would look like this, right? Okay, so let's go backwards. If h is increasing, what sign was h prime down here? Positive. If h is decreasing, what sign should have been here? Negative. So guys, which one is the answer? Is it A or B? It's B, and that's why it's circled. Haha. Okay, any questions on how to do this one? Okay, guys, again, please take a look at this. This is definitely on your test. I think this is a multiple choice. I give you 4 multiple choices just to confuse you, okay? But make sure you know how to choose the right one. All right, let's look at homework from last night. Check your homework, please. And call out the ones you'd like to do. Two, okay. We good? Everybody got 7? Okay, here we go.
Wait, can you number 7?
Yes, I can do 7. All right, guys, we're looking at number 2. Okay, so let's think about what's going on here on number 2. Okay, over here you have an f prime graph. Guys, this is my boy f prime, okay? Please don't call him f. Please don't call him f double prime. You guys good with that? This is f prime, all right? Guys, even without, like, looking at the question, where is f prime positive? Even without looking at the question, where is f prime positive? Do you see f prime is positive there? Everybody good with that? Okay. Where is f prime increasing? A different question from f prime positive. Where is f prime increasing? Here and here. Everybody good with that? So the increasing and positive are not the same things, okay? And this is my boy f prime. All right. Let's look at this. For what values, let's see, for what values of the graph is f concave upwards? So remember, we can't see f. F is in another room, okay? So what we have to do is depend on this notation that we have to figure out what is going on, okay? So f concave up, when f prime is what? Increasing. Everybody good with that? So remember, I only know f prime, okay? So remember, you guys told me f prime is increasing here, and f prime is increasing here. And so the answer must be 2 to 4 or 6 to 10. Okay, this is the answer. Is there a 2 to 4? No, so that's the answer. Okay, is everybody good with that? Okay. Any other questions besides 7, guys? I'll do 7, but any other questions besides 7? Number 5. Okay, let's move to number 5, guys. 5, guys. Okay. This is a good one. You don't have to pretend, okay? Just don't laugh. Okay, here we go. Okay, this again is f prime. Okay, guys. Now, before we look at the question, because the thing is, when we look at the question, we'll get all confused. Okay, let's just look at the picture. Where is f prime positive? Right? That's where f prime is greater than 0. Guys, where is f prime negative? No place. There's no place where f prime is negative. Everybody good with that? Okay. Let's answer this question. Where is f prime increasing? This is my f prime boy. Is he increasing everywhere? No. No, he's actually doing what? He's actually decreasing. You guys good with that? Okay, so you guys agree f prime is never increasing in this picture. And also f prime is never negative in this picture, right? All right, let's look at the question. All right, the question is, where is the function decreasing? Okay, so if you go look at what we've memorized on the notation, okay, the function is decreasing when f prime is what? Negative. What did we say about f prime being negative? It never happens. And so therefore the answer is never. No values. Okay? And if you're confused by this one, I said this is a tricky question. It's because you got increasing confused with positive or decreasing confused with negative or something like that. Does that make sense? Okay, so make sure you understand. Positive and increasing are not the same things. You can have both going on at the same time. Why do I say that? Look at your calculus grade. It's positive, but it's decreasing. Positive and decreasing are not the same things, right? Okay? All right, let's look at this problem here. Okay, you've got f prime here, okay? And the question is, which one is f? Ooh, which one is f? Okay, a little bit tougher of a question. Guys, this kind of question is all over the AP exam. Okay, and we got to kind of just think about things that we know. All right, first thing, guys, just look at my boy f prime. You guys good? Look at this. Where is f prime positive? The whole thing, right? Except for where there's a vertical asymptote, the whole thing, right? Where is f prime negative? Never. F prime is never negative. Okay? Look at my picture again, guys. Where is f prime increasing? Where's f prime increasing? Right here. Where is f prime decreasing? Everybody good? Yeah, right there. Okay. Right there is always the right answer. Okay. Just like at church, Jesus. You're right. Okay. So here we go. If this is true, okay, remember, this is the derivative of this f, right? Okay, so for sure, there's no derivative right here. You agree with that? Yeah. Okay, there's no derivative. I mean, f prime is d and e right here. You agree with that? F prime is d and e. Okay? Guys, when f prime is d and e, if you have no derivative, okay, I'm like you and you're like me, no derivative. Okay, no differentiability. Well, I'm trying to help you guys out. Okay, all right. When do I have no differentiability? When I have what? Sharp turn. So guys, right here, there must be a sharp turn, or vertical tangent, or a discontinuity. You guys good with that? So right here, guys, let's look at this part right here. Right here. Do you guys see it's continuous here, right? So it's not this picture, okay? You have to have a sharp turn, a vertical tangent, or a discontinuity, okay? Let's look at this picture right here. Is there a sharp turn, vertical tangent, or discontinuity? No, it's a point. It's a point y equals 0. All right, over here, right there, is there a sharp turn, vertical tangent, or discontinuity? Yeah, there's an infinite discontinuity. It's called a vertical asymptote. Okay, guys, right here, do I have a sharp turn, vertical tangent, or discontinuity? Yeah, there's a sharp turn. Okay, so we've narrowed it down. Oops, let's go over here. C. Guys, right here, is there a sharp turn, vertical tangent, or discontinuity? No. Okay, so far it's going to be B or E. Okay, let's narrow it down. Let's see what's going on here. Guys, remember, when f prime is positive, guys, remember you told me that f prime is always positive, right? You agree with that? F prime is always positive. I know it looks like it's negative here, okay, but that's because you're looking at decreasing, okay? But f prime is always positive in this graph, except for the vertical asymptote. All right, so guys, if f prime is positive, then f is what? Increasing. So guys, that means f must always be increasing. So you see f is increasing here. Is f increasing here? Yes. So this is the answer, because look at this one. Is f increasing here? No. So this is not the answer. You can even go here and say, look, f always has to be increasing. Is f increasing here? No. So this cannot be the answer. Guys, f always has to be increasing. Is f increasing here? No, that's not the answer. This one actually could be the answer because f is always increasing, but it doesn't match. That vertical asymptote thing doesn't match the discontinuity, okay? So the answer must be B, okay? One of your harder questions for sure, okay, but in about, I don't know, like say 2 weeks, it shouldn't be hard for you anymore because you'll have harder things to worry about, okay? All right, I mean, that's just how it works, right? Okay, all right, let's look at some new things for today. Okay, and it's actually not super, well, it's actually kind of difficult to understand, but it's not super hard or anything. Okay, here we go. These things you already know. Okay, this is kind of a summary of everything that you know. You know the first derivatives test, okay, some keywords for when to use the first derivatives test. Relative max, relative min, increasing, decreasing. You have those words memorized, okay? That's when you use the first derivatives test, okay? We also have what's called a concavity test, which is this notation that you've already memorized. Keywords for concavity test. Concave up, concave down, POI. Can you memorize that, okay? And then you have what's called the second derivatives test, okay? So let me do a new slide, okay? So we have the second derivatives test, okay, which we learned. And that is to find, what are the keywords there? When would you use the second derivatives test? Relative max, relative min, okay? And guys, this is when you use what God gave you. This one, though, happens at a point. Okay, so this one you actually have to find a C value. Okay, what do I mean? When f prime at that point is equal to 0, and when f double prime at that point is less than 0, okay, use what God gave you. F double prime less than 0 means concave down. So guys, do I have a relative max or a relative min? Relative max at that point. So this would be a relative max at x equals c. And then the other side of the second derivatives test says if I have at that point the first derivative equal to 0 at that point, and the second derivative at that point, okay, is greater than 0, okay, be careful, use what God gave you, greater than 0, concave up, at double prime, right, greater than 0, concave up, relative min or relative max? Relative min, okay, so this would say there's a relative min at x equals c. Okay, any questions about the second derivative test? Okay, again, that's for relative max and relative min. If they give you the point, that's a key time to use the second derivative test. You guys good with that? If they give you the point. If they don't give you the point, probably first derivatives, because you have to go find the critical point anyway. Okay? All right, let's look at our new test. If I asked you for an absolute max or an absolute min, which test would you use? The candidates test. Very good. You would use the candidates test, okay? On the candidates test, do you remember, it's been a long time, but on the candidates test, what two types of points do you need to know? The endpoints and the critical points. Okay, you guys good with that? But the other thing that you need to know is you need to know what your f of x is. Does that make sense? Because if you don't know your f of x, how do you plug into here? Does that make sense? Okay, so you need to know your endpoints, your critical points, and you need to know your f of x, okay? The thing is, sometimes you don't know your f of x, or sometimes you don't know your endpoints, okay? There's a special case for absolute max and absolute min, so let me just show you. It's a special case for absolute max and absolute min to find absolute max or absolute min, and that is this. And so I'm going to give it to you as a sketch first so you can understand it, then I'll give you the justification, okay? If you have a picture where I just have one critical point, okay, let's say my critical point is C1. If I just have one critical point, and to the left of that critical point, this derivative is always greater than 0, right? It's positive, right? And to the right of that critical point, this derivative, okay, is less than 0. Do you see it's always negative? Then this point here, not only is it a relative max, because f prime changed from positive to negative. That makes it a relative max. But it's also an absolute max. It is, because it's the only relative max. Does that make sense? And there's no other critical points. Now, if I had another critical point, so let's say this curve turns back up and goes this way. Okay, now this is no longer guaranteed to be the absolute max. You guys see that? Okay, you can only have one critical point, meaning this over here, this curve must always be a positive slope, right? If this curve ever changes to be a negative slope, then this is no longer the absolute max. Are you guys good with that? Okay, so that's how this justification goes. It goes, if you only have one critical point, okay, at that critical point, it's going to be an absolute max if on the left the derivative is always positive, and if on the right the derivative is always negative. Okay, so let me write that justification. The justification looks like this. There is only one critical point at x equals c1. Okay, and then you'd say when when x is less than c1, then your derivative must be greater than 0. And when x is bigger than c1, then your derivative is less than 0. Therefore, you will have an absolute max at c1. Okay? The justification is a bear to write down, but it's pretty easy to understand. Okay, you guys agree with that? It's terrible to write down, and sometimes you will have to write it down, but it's pretty easy to understand. All right? On the flip side of this, okay, how could I show an absolute min? So this is in a special case, okay? Oops, I wanted to do a different color. So in a special case, okay, so the opposite, right? If I just have one critical point here, I'll call this point C2, okay? And all the derivatives to the left of this point, the derivative to the left of this point are what? Is this negative? Is less than 0, okay? And all the derivatives to the right of this point is positive or greater than 0. And of course, you could say positive or negative if you like that better. F prime is positive, okay? Then at this critical point, not only is there a relative max, I mean, we already know there's a relative max, right? Because f prime changes from negative to positive, okay? But there's also, did I say relative max? Sorry, relative min, okay? Not only is it a relative min, because f prime changes from negative to positive, it is also an absolute min, okay? So I'm going to focus on the absolute min part here, okay? The justification looks like this. There is only one critical point at x equals c2, okay? And when x is less than c2, so when you're at the left of c2, the derivative is always negative. And when x is greater than c2, the derivative, and technically it's the derivative at x, is always positive, okay, at every x. Therefore, there must be an absolute min at x equals c2. Okay, and this is your last justification that you have to learn, and it's pretty terrible, I admit, but it's not hard to understand. Okay, and on your homework, you're going to have something similar. And actually, if you get this, see if this makes sense. The relative mins and maxes always occur at critical points, right? And if you have an absolute min or max, it'll occur, except for the endpoints, it'll occur at the critical points for this problem. Does that make sense? And that's why we say, look at the critical point, okay? But guys, what if I told you this? Let's say there's more than one critical point, okay? Let's say there's another critical point. Let's say right here, there's a horizontal tangent line, and I keep moving up, okay? Guys, do you see that this would still be the absolute min, right? Okay, so truthfully, just as long as this, to the left, this slope is always negative, and to the right, this slope is always positive or equal to 0, okay, then this is still the absolute min. Okay, so you could write that as your justification too. To the left of C2, the slope is always negative. To the right of C2, the slope is always either positive or equal to 0. Okay, therefore, this is their absolute min. Okay, yes?
So if you have that, then in your first part of the justification, you wouldn't say there's only one critical point?
Yeah, you wouldn't say there's only one critical point because it isn't true. Okay, but you could see kind of using the same principles that this would be an absolute min if this were always negative or equal to 0. If to the right the slope is always positive or equal to 0, then therefore this is absolute min also.
So you'd like just write the second part?
You would just write the second part, yes. Except you would change this to, see if this makes sense. And you can actually change it now if you wanted to. You could change it to less than or equal to 0. F prime is greater than or equal to 0, right? Because you have an equal here at this horizontal tangent line. Okay, that was just to confuse you more. Okay, but when you get to your worksheet, it'll make sense. All right, and that's really all I have for you today. Okay, so go ahead and start working on your worksheet. I'm going to walk around and help you guys out. Yeah, Brett?
Can you check that mark from the one
Yes.
Friday?
Yes, I can.